Welcome, welcome, welcome. I'm Lisa Blackburn. This is my YouTube channel where I talk about everything I want to science and math. And what we're doing today is balancing chemical reactions. So if you're in my classes at East Paulding High School, this is our new unit. This is unit, I have to look at my thing over here, unit 5. And you can see our standard on the board over here. What we're going to be doing for unit 5 is the first half of standard 3, everything in red. The green will be the next test, which is a very mathy test. So make sure you got those calculators and bring in them every day. These are our essential questions. What are the indicators of a chemical reaction, and how do I balance a chemical reaction? So that's what we're going to try to answer today. And we're not going to do much notes because my allergies are bothering me. And I need to let the Claritin build up in my system. All right. So first of all, what is a chemical reaction? Let me get my notes here. A chemical reaction is a chemical change. Let's see if this is right. Yes, it does. And do you remember the symbol for change in science and math? A triangle. So we don't have to write it. As a chemical change, one or more substance being changed into something new. The original substance is called the reactants. Did y'all ever learn this in your previous life? Yes. Good. Somebody said that they did some chemistry in middle school. When?
Mr. Curtis did in biology a lot.
Oh, good. Excellent. Excellent. And the new substance is called what?
Product.
The products. Very good. So, how do we know that there is a chemical change, a chemical reaction? Now, the symbol for reaction is RXN. RXN. So you don't have to write reaction and tire your hand out. You can write RXN. So let's look at a chemical change and see if you can spot the evidence for this chemical change. Now, got to have my lab safety here. Pull back long hair. Because I don't want to catch my hair on fire either. It's not working. My hair's not working. This makes very good YouTube. Watching someone pull up their hair. All right, that's better. I can feel it. I can feel the hair is better. All right. I have another one. No, I'll have to open this one. All right, so I'm going to do a very exciting chemical reaction for you. Oh, and also, you're going to do this chemical reaction too, so. I'll step back around onto the TV. All right, here's my chemical reaction. Okay, watch carefully. What are evidence? How do we know that this is a chemical reaction? What do we see? Okay, so let's talk about flame is a judgment. We're going to try another one. Flame is a judgment. What's a better way? Somebody said it. What? Heat and... Okay, wait a second. Let's talk about that. So we have heat. Someone said light. Smoke. So formation of a gas. Changing color. Do you see how the stick is changing from tan to black? And what? The color of the fire. That identifies it, right? Now, I'm going to start with another one. Because I've been too loud. Y'all listen. Yeah. Can you hear it? If you're real quiet. You hear that little popping and crackling? So there was a noise that goes with it. Okay, so I think y'all did good. Y'all did good picking them all. All right, so this is the other thing. I have discovered, much to my shock, that there are 15-year-olds and 16-year-olds who have never struck a match before. So just like I made you all light the burner, I want everybody to strike the match today. that I want you to know how to do this and not be afraid to push on it and strike a match, okay? Because this is an important chemical reaction. You'll use in real life. You might need it. So like, start a campfire or something. So I got a whole box. So one of the things I want you to do is strike a match. Now, don't take the hot match and throw it in the trash can and catch it on fire. Notice that I just laid them on the countertop. We have great countertops here. They're heat proof. And so you can do that too until it's cool, and then you can throw it away. Any questions about your hands-on activity today? Have a lot of you already struck matches before? In every class, I found kids who have never done it before. And you just got to. So everybody's got to strike the match. All right. So let's write it down. Evidence of a chemical change is heat. And really it is a change in heat. It could get real cold instead of getting hot. Light is evidence of a chemical change being given off. Noise. Remember in our video where we saw where he had the hydrogen and he did the spark and it went, "Er!" It made that really loud thing. That was that thing. Another one is color change. Color change. It made a gas, production of a gas. And it could form a solid if you mix two liquids together. And that's called a solid precipitate, which just means that it makes some powder, and that's the abbreviation for precipitate. And also the symbol for a precipitate is an arrow down, and the symbol for forming a gas is an arrow up. Now, reactions can either release or absorb energy. If it gives off energy, it is called exothermic. So that's the second one I said at first, because I think it's easier to remember. Because it sounds like exit. Exo, exit. The energy is exiting. So do you think that one's hot or cold? If it's exiting energy. What? The energy's all going out. So the energy was in my match and then it went out. So it's going to be hot. And then the other one, endo, it's sucking the energy in. And so it takes in energy. Now we're going to do a whole unit on energy on this later, but we're just going into it. An example is when in our video, when they took the water and they kept zapping it and making the gas. Remember in Adam's Ring of Truth when he kept making the gas and he said, there's something about water that knows math, because no matter if we do this all day, you always get 2 parts hydrogen for 1 part oxygen. Remember that? So this is the example of that. It's water plus energy yields hydrogen gas and oxygen gas. Also, another one is, for the endothermic, is cold packs. You know what I'm talking about? They're in the first aid kit. You break it, you shake it, it gets real cold, and you put it on what got hurt. Have y'all seen those? I used to coach baseball. I know y'all are shocked, but I did. I was a batting coach. I know you're shocked, but I did. And but I was also in charge of the first aid kit. It was for like 12-year-old boys on their team, and we had to go through those cold packs. Oh, people would slide and get hurt and fall down, and just go through those cold packs. If you give them a Band-Aid and a cold pack, you can walk off a lot of sports-related injuries. Y'all know what I'm talking about, the cold packs? Yeah. I'd bring them, but they're kind of expensive. But I've got some other reactions. You'll get to see they're endothermic. All right, the next one, an example of an exothermic reaction. Let's see what I put for that. You can reverse this reaction. You can take the hydrogen gas plus the oxygen gas, and it can be combined, and it makes water, H2O, plus energy. Another one example of this is hot hands. The one where you break something, shake it, and it gets hot. You've seen those. There are a lot of times they're impulse items in the winter. But they're one also. Okay, fun exothermic reactions. Fun exothermic facts. The reaction is more stable once the bonds form. The stronger the bond, the more energy that could be released. And the great majority of reactions are exothermic. Oh, that little pen is not working too good. J. That's not too bad. The great majority of reactions are exothermic. Okay. And then our next thing is that atoms are rearranged in a chemical change. Bonds are broken and new bonds formed. Okay, the next thing, let's have a little more water. All right, you must obey the law of conservation of mass and energy. Matter and energy. What's the symbol for energy? Big E. Cannot be created or destroyed, only change forms. And then the other thing is particles must collide for a chemical reaction to occur. The example was the match. Excuse me. See if I can get through this. Are we worried that the matches are going to just start burning? No. They have to come in contact with this chemical. This is a chemical. And the two chemicals must come in contact for the reaction to occur and for the burning to start. Now, they used to have strike-anywhere matches where they put both chemicals in one match, and on any rough surface, it would push them together and it would start. And guys would use their beard and light a match on it, or the bottom of their boot. You'd see it in the old westerns. The problem is if they got hot, they would just combust. So people would leave them in their cars. They'd catch on fire, burn the car up. You come back after a movie, your car is all burnt up. So you don't usually see those anymore, strike-anywhere matches. Has anybody ever done that before? Had strike-anywhere and taken them out to the sidewalk and struck them on the concrete? They're pretty fun. Pretty fun. All right. Oh, sorry. All right, let's see. Now, what we do with these reactions. Accurate chemical reactions. We're going to go on to the next thing. Chemical reactions are like a recipe. So I make chemicals all the time. Like I made this. Here's a little calcium chloride I'm going to use for a demonstration in the next part of the notes tomorrow. And how I know how to make it is by using the periodic table and a balanced chemical reaction. Okay? So they are like recipes for chemical products. Now, cooking is actually chemistry. When you cook something, you're doing a chemical reaction. Just like with our matches, we can't get it back to wood and chemicals again, can we? It's all done. There's no putting it back. Well, this is a recipe for peanut butter cookies. And once you make the cookies, you can't get it back to eggs and vanilla and sugar and peanut butter, can you? Okay, so this is also a chemical reaction. And there's a lot of shows, they're out on YouTube, you can watch them about the chemistry of cooking. What was that guy? Lived in Marietta, little glasses. Anyway, he had a whole show on Food Network about the chemistry of cooking. So that is like something you could go into. If you like chemistry, you like cooking, there are jobs that combine those things. So it's kind of interesting. Now, what do you notice? My recipe is a cup of peanut butter, a cup of sugar, 1 egg, 1 teaspoon of vanilla, 1 batch of peanut butter cookies. So that's what you put in, that's what you get out, that's how you write it. I wrote my reaction, my recipe the way we write chemical reactions, which is different than regular recipes. What do you notice unusual about my recipe? What does it not have? Flour. So I have a little story about this reaction. My next door neighbor, growing up, Mabel Johnson, won the Pillsbury Bake Off. I think she got $50,000 in a new kitchen. Maybe it was $100,000. She won. And but she won with a different recipe. But she was like a runner-up with this one. So she invented this recipe. It is a peanut butter cookie that uses the protein in the peanut butter instead of flour in the recipe. Well, now you see this recipe everywhere because people are all gluten-free. This is the recipe that people who can't have gluten use when they want to make cookies because no flour. So it's very funny. I know her. I know the lady who made this recipe. The weird thing is she won with this recipe for savory cookies that were onion cookies that you eat with soup. They were onion cookies. That's what she won with. That was her award-winning one. This one that is delicious and has gone viral didn't win. She won with the onion cookies. But she won. All new appliances, new cabinets, new kitchen, and a whole bunch of money. So Mabel Johnson, I know her. So anyway, what I used to do was, when we got to this point, is I would let my students who were missing a test or a lab bring in to cook the cookies and bring them in and share them with the class for a lab makeup. But y'all are all allergic to peanuts now, and I'd be killing some kids, so we can't do that anymore. Now, so what I did last semester is, if people wanted to do it as a bonus or as a makeup, I let them make the cookies or some other cookies. And if you do other cookies, you have to write the recipe as a chemical reaction and take a picture of yourself at your house with your cookies and submit it through Canvas. And then you had to bring in 3 cookies to me so I could see that you really bought them and you didn't buy them, that they're really homemade cookies and stuff like that. And I'd ask you some questions about the chemistry of it. Now, y'all are not as behind as the other classes have been, but I'll think about it if y'all want to do the cookie lab makeup, because cooking is chemistry. So we can pull in more chemistry to any cookie. Okay. All right, so let's move on. Next idea is that atoms and masses are conserved in a chemical reaction. And coefficients indicate the amounts. I'll explain to you what this means. All right, so reactions must be balanced. So what this means is, all that's fancy science talk. For what you put in is what you get out. You can't create or destroy atoms. What you put in is what you get out. Does that make sense? Okay, now, when you balance a chemical reaction, you change the numbers in front. You don't mess with the little numbers down below, because if you did, it would be a new substance. If you just put a 2 after that oxygen, yeah, the numbers would all balance out, but you wouldn't have nice water anymore. You'd have hydrogen peroxide, and if you drank it, it would kill you. So you can't go messing with the little numbers. You can only put big numbers in front. So these are the rules, okay? Do not change subscripts, the little numbers at the bottom. Or that would be changing chemicals. You do change coefficients. Coefficients. And those are big numbers. In front. Okay? Never insert a number between elements in the same molecule. Now, we're going to do some examples, but first, y'all know y'all are the honors gifted class. And I was reading a paper out of England about a guy, and he said that honor students need this little exercise we're going to do from time to time. Y'all don't get to think enough. Y'all get bored. Yeah, everything's always too easy for you. So what we're going to do is we're going to see if you can figure out how to do this by yourself. What I want you to do, let me decide which one I want you to do. I sort of want to give you a hard one. Let me find my paper here. That one's too hard. That was not too bad. P2, P4, KClO3. Okay, let's try this one. P4, KClO3, KCl, P2O5. Now, when you do these, I always write the reaction in pen and balance it with pencil, because that way you can erase. So don't be afraid to be wrong. Don't enjoy feeling confused. If you feel confused, that's good. You don't get to get confused enough. Take your time and enjoy the process and see if you can figure it out. I want to see if you can try to balance this equation right here. P4 ClO3 KCl plus P2O5. All right? Now I'm going to stop the tape and we'll come back and we'll do another part where I'll show you all how to do it.